Hello dear students of plus 2 medical, non-medical, respected teachers, dear friends. Today I am going to discuss nuclear fission and nuclear fusion. So first of all, what is nuclear fission reaction? So nuclear fission means the phenomenon of splitting a heavy nucleus having mass number more than 230 into two or more lighter nuclei with the release of huge amount of energy is called nuclear fission. And the mass of the product nucleus, total mass of product nucleus is always less than the mass of the reactants. So this difference in mass is called mass defect, and the energy released is calculated using formula E is equal to delta m c square. So for example, when uranium 92 to 35 is bombarded with a thermal neutron. What are thermal neutrons? Fast moving neutrons. Then it splits into barium 56141, krypton 3692, and 3 neutrons are produced and huge amount of energy is released. So this amount of energy is shared by these product nuclei and neutrons, where delta m, that is mass of all these product components minus the mass of the reactant components. Delta m is equal to 0.2153 AMU, and if we calculate energy corresponding to this mass defect, it comes out to be about 200 MeV. So during per fission, amount of energy released is 200 MeV, and a very short time of the order of nanosecond, 10 is minus 9 second. Okay, then this reaction continues and nuclear chain reaction is formed because these three neutrons produced in this fission may react with three other uranium atoms, and 9 neutrons are produced, and these 9 neutrons are then further reacted with 9 neutrons, 27 9 uranium atoms, 27 neutrons will be produced, and so on. So this reaction becomes uncontrolled if it is not controlled. So this is a chain reaction. So when this is a uranium 235, 1 neutron is bombarded, so it gives barium, krypton like this, and then 3 neutrons. These 3 neutrons further split 3 uranium 235, and 9 neutrons are produced, and so on. This process continues. Such a reaction is known as nuclear chain reaction. It may become uncontrolled if it is not controlled. So, and this uncontrolled nuclear chain reaction is the principle of an atom bomb. Now, when we control this nuclear chain reaction, so it can be used for constructive purpose. And if it is uncontrolled, it is only used for destructive purpose. So, controlled chain reaction is used to construct devices like nuclear reactor or nuclear pipe, which are used to generate electricity and other things. So, to control this nuclear chain reaction, for example, if we have to make an atom bomb, safe atom bomb, it does not explode automatically. So, it is made of two pieces. The size of each piece is less than some critical size, because when size of the sample increases more than the critical size, some particular size, then reaction becomes uncontrolled. That's why it is made two pieces. These two pieces are separated by strong cadmium partition. So when bomb has to be exploded, this cadmium partition has to be removed. It is placed in a strong container, made of a strong material, so to produce a powerful explosion. So that particular size before which the reaction is controlled is called critical size, and the mass of the sample is known as critical mass. So to control this reaction, we use the factor neutron production factor. To control this chain reaction, what we have to do? We have to control the production of neutrons. If the production of neutrons increases abruptly, the chain reaction will become uncontrolled in a very short time of the order of microseconds. So, K neutron reproduction factor is defined as the ratio of rate of production of neutrons to the rate of loss of neutrons. अगर 10 न्यूट्रॉन प्रोड्यूस हो रहे हैं तो 2 लॉस हो रहे हैं तो 1 रहेगा तो रिएक्शन सस्टेन्ड रहेगी. जो 10 न्यूट्रॉन प्रोड्यूस हो रहे हैं तो 9 बन रहे हैं, 27 हो रहे हैं, तो रिएक्शन विल बी अनकंट्रोल्ड. जे नंबर ऑफ न्यूट्रॉन्स घट रहे हैं, प्रोडक्शन घट रही है तो रिएक्शन विल जी डाई आउट आफ्टर सम टाइम. So depending upon the neutron reproduction factor, so we can see how this happens. When K is equal to 1, nuclear reaction is sustained and steady. That is, if rate of production of neutrons and rate of loss of neutrons remain the same, then reaction is said to be steady and sustained, means that can be used for constructive purpose, and that is the principle of nuclear reactor. And the mass of the sample is said to be critical, and size is said to be also critical size. Mass said to be critical mass. So this state is critical state. When K is greater than 1, chain reaction, nuclear chain reaction becomes uncontrolled, and it is said to be supercritical stage, and mass is said to be supercritical mass, size is said to be supercritical size, and this is the principle of atom bomb explosion will take place soon. If K is less than 1, reaction goes to halt sometime, and the situation is state is subcritical, mass is called subcritical mass, and size is called subcritical size. So this is how we control the chain reaction, nuclear chain reaction. So nuclear chain reaction is controlled from the knowledge of neutron reproduction factor. So this uncontrolled nuclear chain reaction is the principle of atom bomb. Then nuclear fusion, the phenomenon of fusing of 2 or more lighter nuclei into a heavy nucleus is known as nuclear fusion. So when 2 lighter nuclei fuse to form a more heavy nucleus, and huge amount of energy is released. And again, energy released is given by E is equal to delta mc square, because mass of products is always less than the mass of reactants. This difference in mass is converted into energy, which is carried out by the product particles, nucleus, and it may appear in the form of gamma radiation. For example, 1H1, when 2 protons combine 1H1, it gives 1H2 plus a proton, a neutrino, and about 0.42 MeV particle energy is emitted. So many examples. When 1H2 and 1H2, when 1 deuteron, combination of 2, when 2 deuterons fuse to each other, when 2 deuterons fuse, then we get 2He3 plus a neutron is produced, and 3.27 MeV energy is released. In 1H2 neutron may also get fused and 1H3 plus 1H1 proton like this, and 4.03 MeV will be released. Even 1H2, 1H2 neutron may also fuse together to form He24, and 24 MeV energy is released in the form of radiations. No, energy per fusion we can see is 24 MeV. Energy per fission is about 200 MeV. But energy per unit mass produced during nuclear fusion is very large as compared to energy per unit mass produced during nuclear fission. So because the lighter nuclei, so total energy per unit mass you calculate depending on sample mass. So in case of nuclear fusion, energy is very large as compared to nuclear fission. So that's why this is the basis of principle of hydrogen bomb. So it means hydrogen bomb is very stronger, much stronger than atom bomb. Basically, in hydrogen bomb, to fuse to lighter nuclei, we need a high temperature, which can be maintained only with the help of explosion of an atom bomb. So atom bomb, you can say atom bomb is a part of hydrogen bomb. So hydrogen bomb is more dangerous. So for example, God made hydrogen bomb in our sun, gives us energy, gives us life, but man-made hydrogen bomb gives destruction. Yes, if we control this nuclear energy, we can use it for productive, constructive purpose, and that is done in case of nuclear reactors. There are so many nuclear reactors used in India, so in abroad. So this is all about nuclear fission and nuclear fusion. So till next video, stay tuned. Good luck. Be happy. All the best. Sarbat Dapala.